Friends, very good morning to all of you. Today's class topic is the application of UV spectroscopy in the characterization of the organic compound. So in this video, we will talk about the applications of the ultraviolet spectroscopy. So here there are 15 applications I have mentioned in this topic. So just you can take the screenshot and you can write the points, and depends upon the students how much they want to write in the exam, and depend upon the how much mark question it comes. So now let us start. So first application is the detection of the functional group. So we will see the detection of the functional group. So first application is the detection of the functional group. So UV detects the presence or the absence of the chromophore if any functional group is present. As we know that the important application of the ultraviolet spectroscopy, if any functional group is present in any molecule, it can identify easily. So if it will show the band in the ultraviolet region, and what is ultraviolet range? It is 200 nanometer to 400 nanometer, means the main ultraviolet range is from 200 to 400 nanometer. So if any functional group is present in any compound, it will show the absorption between the 200 to 400 nanometer range. And if there is no absorption above 200, it means the molecule will lack the conjugation, carbonyl group, benzene or the aromatic compound, bromo or the iodo atoms. Means if the molecule does not absorb the radiations in the above the 200 nanometer range, it means the molecule will have the absence of conjugation, carbonyl group, benzene or the aromatic compounds, bromo or the iodo compounds. So the some important ultraviolet absorption band due to the functional groups are mentioned here. So you can pen down, and in the last I will again share this part. So suppose if any molecule is having our benzene ring, so the absorption of the lambda max value will range from 203.5 nanometers. And if any compound is having our acetic group, COOH group, the lambda max value will be 208, means absorption will takes place above the 200. And if any carbonyl group is there, carboxyl group is there, C double bond, the value will be 189. So just these are examples, anyone you can write. So if any functional group is present in the molecule, the absorption will takes place above the 200 nanometers. So second application is the extent of the conjugation. I hope already know what is conjugation. One single bond, double bond, alternate manner. So easy always to understand the 1,3-butadiene structure. So here, if suppose the molecule have n number of the conjugation, definitely it can be easily detected by the ultraviolet spectrophotometer. And whenever any double bond is added, means if the conjugation increases, definitely the value of lambda max also increases. That is our bathochromic shift. Okay, so if suppose the number of n, means if the double bonds is 8, so the absorption will occur in the visible region. As we study this UV visible spectrum together, so it ranges from 400 nanometer to 800 nanometers. So and UV is 200 to 400, and if it is visible also, it's 400 to 800. So if suppose the conjugation n equals to 8, the absorption occurs in the visible region, and that ranges from 400, and the lambda max value for that absorption will be 400 nanometer. So such alkenes are colored to the human eye. Now, for example, our lycopene that is present in the tomato also, I have already explained in the first part of ultraviolet spectrum. So its absorption values is above the 500 because there are 11 double bonds. Now next is the identification of unknown compound. So suppose if any unknown compound is there, and if suppose we are talking about phenol, okay, if we are talking about the phenol, or we are talking about the nitrophenol, so if suppose some sample is having the same molecular structure, so if the compound is having the same structure, so the spectra of this compound should coincide, otherwise that sample is different. Means if any unknown sample is given and you have to identify, and we know that this compound, the spectrum of any compound you are already knowing, so if the spectra coincide, then it's the final product, otherwise the sample is different. So easily identify the unknown compound. So just in the same manner we are identifying the samples of our other planets. No, they will give some sample that this compound is found in this area. So just we have to identify the nature of the compound, that is known or unknown compound. So next application is the determination of the configuration of the geometrical isomers. We know that geometrical isomers present in the two forms, that is cis and trans. So here example I have taken of the cis. This is still being structure C6H5 CH double bond CH C6H5. So this is cis stilbene and this is our trans stilbene. So we can easily determine which is our cis isomer, which is our trans isomer. So in case of, if the isomer is cis, so there will be steric hindrance. These two groups, okay, they will clash each other, means there is some steric hindrance, there are some bulky group. So because of this will suffer a distortion and the absorption will occur at the lower wavelength in the case of the cis conformer, cis isomer. So this structure, the cis stilbene, the lambda max value is 278 nanometer and the this E value is 9350. Here for the trans stilbene, the values for the lambda max is 295 nanometer and the values for the E is over 24,000. Both values are more in the case of the trans. Then next is the distinction in the conjugated and non-conjugated compound. So we know that conjugation means alternate single and the double bond. So you can see this first compound, there is conjugation, this double bond, single bond, double bond. You can see this compound, double bond, single means that it lacks the conjugation. So when we will take the UV spectrum of this compound, so for the first case, as the conjugation is present, it will absorb at the higher wavelength. So this easily compare the compounds from the first and the second. Next is the preference over the two tautomeric forms. So I hope you have studied the tautoisomerism, keto-enol tautomerism. So this is ketone group, this is alcohol group. Keto-enol tautomerism is shown in these two compounds. This is our 2-hydroxypyridine and this is our pyridone 2. So if we see the structure of the two compounds, so it will favor for the pyridone 2. Again, why? We can see the conjugation, double bond, single bond, double bond. So it's alpha beta unsaturated compound and the equilibrium will shift towards our pyridone 2 side, means this compound will absorb at the higher wavelength. So this is easy example, only 1-2 lines you have to write. Distinction between the equatorial and axial conformations. So when you study about the conformation, you remember our eclipse conformations. Okay, so when we are talking about the cyclohexane, there were axial. So what is axial? When it is perpendicular, 90 degree जब आप straight line draw करते हैं, and what is equatorial? When it is little bit oblique. So when we talk about the how we can distinguish between the equatorial and axial conformation. So again here we have taken the two example. In the first example, this our bromine group is placed at the equatorial position and here it is present at the axial position. So how we can identify this? So there are some R type of the bands which for the case of the axial, this R band will absorb at the higher, they show the large value for the UV absorption. So as compared to our equatorial, so just you have to draw the structure nicely and both are same. The difference is in this equatorial position bromine atom is present and in this equatorial hydrogen. So for the case of axial you will get more value for the lambda max. So we can easily distinguish between the equatorial and the axial conformations. Next is the elucidation of the structure of the vitamin A and K. So as we know that there are so many double bonds or so much conjugation in the structures of the vitamins, and so here we can see this structures of the vitamin A1 and A2. I think both appears to be the same, but when we see their lambda max value, so for the case of our vitamin A1, the value is 325 nanometer and the value for A2 are two values, that is 287 nanometer and 351 nanometer. Why this extra values here? Because in both the structures, in the structure of vitamin A2, there is one extra ethylenic bond. So because of the presence of this ethylenic bond, the values is there is one separate value, that is 351 you will get for the vitamin A2. So we can easily elucidate the structures of the vitamins with the help of our UV spectrum. Next application is the examination of the polynuclear hydrocarbons. So as we know that there are so many polynuclear hydrocarbons. If you see the rings, means so many benzene rings are attached to each other one after the other. So as the number of the rings increases, so what is the important here in the UV spectroscopy? As the number of rings increases in any polynuclear hydrocarbon, the lambda max value will go on increasing. Okay, so the lambda max value will go on increasing as the number of rings increases in the groups. Next is the detection of the impurities. So in the ultraviolet spectroscopy, it is very important tool for identification of the impurities in any particular sample. So suppose if 0.05% impurities is also present in the sample, it can give the E values that up to 2000, means if छोटा सा भी impurity होगा easily detect कर सकते हैं. So the impurities of cyclohexane in benzene can also be detected by its absorption at 255 nanometers. So if any impurities are present, we can easily identify with the help of UV spectrum. So this 10 applications I have discussed here. So just you can take the screenshots and do complete your notes. If you want more applications details, you can write to me. I will share the details. I think 5 mark question, it is sufficient. And if you are having any doubts, you can ask to me. So these are the total number of applications. There I have mentioned the 15 applications in the you can write the 15 application, and how much you want to explain, 5 or 10 you can explain. Thanks for watching. Do subscribe the channel, and in the last you will have and take the picture of this particular functional group table or note down, because sometimes they will ask which functional group absorbed what wavelength.